Okay, I am back. So again, this is Mr. Barden. I'm creating kind of a series of really short videos going over the various circuit building aspects of the Arduino unit of the programming digital media course that I teach. I have a new tripod to kind of help mount some of this, so I'm not just holding my phone while I do it. But because I need to get some of these out to some teachers before too long, I'm going to go ahead and start with the more simpler stuff, and we're just going to kind of deal with my hand holding of the phone for a video or two. So just go with that. I'm also going to be editing this together with the shorter videos where I'm talking about the code that we are running all into one cohesive unit. So let's just kind of hop into this. I've got my Arduino over here. The cable is kind of long and heavy, so it's going down to my desktop down below, and it's kind of pulling everything down bit by bit. I've got a breadboard, which we'll be using to build our circuits. This is a very useful tool that does not require any soldering for circuit building, so it's a handy tool to have. I have some various lengths of jumper wires that we're going to be using as the wires for the circuit. And then over here on my desk, I've got a bunch of different Arduino components. There's way more in here than we'll actually need for the course, but there, it is there, and there are options. A lot of what we're going to be focusing on is going to be built out of the LEDs, or light emitting diodes. Let me pull up a really clear one so we can see it. So basically, a diode is an electrical component that only allows electricity to flow in one direction. I've got one right here that is pretty clear. Let me see if I can focus on that a little bit better. I didn't notice a difference. But if you were to look into it, come on. If I go over the black background, there we go. You can kind of see that there are those two metal points, and this particular diode is a light emitting diode, or LED, as you're probably more common with it. So the electricity will always flow from the positive end, which is the longer wire, through the main component here and out towards ground in this shorter wire. And basically, the electricity is kind of just moving between these two pieces of metal right here. Can I get any closer and it stay in focus? Kind of. And as it does that, it loses a lot of energy in the electrical system, and that is what we see output as light. LEDs come in many shapes and colors. I've got a lot of different ones in here. I'm gonna go with the red ones because the blue ones really blow up on video and are a pain in the butt to see. So let's go with the red ones. So to stick these into our breadboard, you'll notice that there are tons of holes in here. And these holes are designed to put the various components in their leads, is what they're called, into them. They're used to kind of distribute power both vertically and horizontally through the system. So the vertical aspects are these on the side here. You notice they got these big lines. So when you hook it up properly, this will be all the positive voltage here and all the negative voltage on the right side as well. In the middle, though, this is where everything is horizontal. So you'll notice that for down here, there's row 30, and there's 5 sets right there, and we're going on. So anything you plug into on one row, it's all gonna, anything else plugged in on that row will also get the same electricity going from that source. I think that'll be a little more clearer once we actually start building. So I'm actually just gonna hop into it, and I think you'll see as we go along. So I've got my LED here, and I'm gonna plug it in. I'm just gonna go right here, so there's plenty of room before. I mentioned that again, horizontally, they all share electricity, so you want to put this between 2 different numbered rows. For the case of the LED, again, direction is important. If your students are doing this properly, if there's no, like if the LED is in the wrong way, there's not really a risk of it breaking or anyone getting hurt, it just won't turn on. But if they're messing around and not doing things properly, we run into issues. As you can see there, my LED did not want to go in, and it kind of bent up the leads. That is okay. Some of these require a little bit of a little little oomph to get it in there. So we'll connect that. I'm gonna grab some wires here, and for now I'm going to just connect over to my Arduino. There's the power section right here. It's usually labeled power. So I'm going to connect my red wire here to 5 volts. I'm going to go with this green one here for ground. Green will work, brown will work. I mean, the wires are all the same on the inside, but generally speaking, you have your red for the positive power and black or sometimes green. I've seen white a few times too, actually, but those different ones for ground. So you can just get it in there. This is a not very often used one, and I'm also going one-handed, so that's fun. Get into that board. Again, these do not always want to go in, so I'm gonna come back to that one. Negative, get in there. It doesn't really matter which ones they go into because it'll move the electricity through the whole system for right now, but it's really just kind of annoying when they don't want to go into the hole. So I'm going to set this to the side, and I'll keep talking while I get all of these bits into the hole here, because it really just does not want to go in. Okay, well, it's not pretty, but it is in there. So now we've got this little vertical row here is all energized. One thing that's very handy to do with your breadboards is to add another little wire to connect the two sides of the board. So I'm going to go from positive to positive. There we go. And I'm going to grab a similar length wire, and we're going to go from negative into negative if it gets in there. One moment. It's being a real pain today, this breadboard. Just grab the first one I saw, and some of them inside is basically just a bunch of little metal clips, and sometimes things go in nicely, other times it requires just a little bit of oomph to get it in there. So hopefully I'm not doing that a whole bunch, because that just makes for a boring video. Okay, so I've got all of those components in, and the reason I've done this is because, kind of illustrated by this big groove here, is that the little metal clips inside that let the electricity run in the horizontal and vertical patterns don't go all the way through. They stop in the middle. So by doing this, we can get the power and ground from the Arduino sent to both sides of the board very easily. So let's just do some stuff with it now. So I've got right here some 220 ohm resistors. We can have a variety of resistors for what we're doing here. Sometimes we may want bigger ones or smaller ones, but basically the more resistance that the resistor has, the less electricity can flow through it, the system. So I usually find somewhere between 200 and 300, give or take, ohms is generally pretty decent for an LED. So we'll use this a lot. Okay, the long lead is facing me. So what we can do is wire this up just to turn on. So we have to have a resistor of some kind in this system, or else things will start to short circuit. Basically, if you and your students are doing this properly, you won't hurt yourself or anyone, but with any electricity not coming from the Arduino and the computer, this can potentially be dangerous. So again, I want to stress that. So I like to plug my resistors going into ground, so I'm going to take one end there and the other in the same row as the short lead of the LED. So we get this. And then lastly, we can just connect the long lead of the LED. So I'm going to plug into that same row. And then this will go into power here. Get in. It's in enough. It's in there enough to turn on. So again, the way that this circuit is working is that we are getting 5 volts from the Arduino, and more specifically the USB connection and the computer, but we're getting it from there. It's going into the breadboard. It's then coming out of there into the LED. It's going through the LED and then through the resistor back into ground, which is the same ground connected to everything else. And that's what's happening right there. Again, if we stuck the LED in backwards, nothing would happen. If we didn't have if we had a much smaller resistor, would notice the light would be brighter, and if it was a much larger resistor, the light would be a lot dimmer. So I find about 220 or so is a decent one for working with the with LEDs. There's math involved for working this out, but I've seen them, that might be a little on the lower end. I've seen 270 is pretty common, 320 is used. Again, somewhere in that ballpark, and you should be fine, and you won't have anything popping on you. Okay, so that's the first bit there. But if you remember from the code, we have, there it is, we have this blinking LED, and we want to achieve that here with this one. So this is what I'm going to do. Instead of connecting the LED to the always on power, I'm instead going to take a longer wire and I'm going to plug it into pin 13. You should hopefully remember that from the code. That was what we labeled as the LED pin. So I'm going to plug one end of the wire into that same lead, positive lead of the LED. If I can get it in there we are. And then I'm going to come around, and over here on the digital pins, I'm going to find 13, and I'm going to stick it into that hole. I'm going to get that in there while looking through my phone. There we are. So now what we should see is that whenever this LED that's built in turns on, the one in our circuit should also be turning on. I can see it now, you can't. But that's what we can expect to see because, again, this built-in LED on the board is connected to pin 13. This may be different if you're not using the Arduino Uno, but all of the built-in LEDs have a pin that they're attached to. So if we move over here, we should see that now this light is blinking. And if we were to put them kind of both in the same shot, you can see that they are both blinking together. The reason this is working is if you look at the code, we are just saying that every loop we are going to turn on and send electricity to pin 13. We're going to wait for 1,000 milliseconds, and then we are going to turn off the electricity and then go from there. That's pretty much all it is, pretty straightforward. This is the blinking example. This other one is the one we kind of wrapped up with when I recorded the previous video, and this is going to be responding to a button input here. So I'm going to go into my box of stuff and grab a button. I'm going to use this one, little tiny one specifically. I like these red ones, but I haven't used them before, so I don't want to spend part of the video figuring that out. So I'm going to connect it, and I find these work best if you plug them in kind of over this little gap. They're pretty well sized for that. So we're going to have that right there. To wire this up, it's going to be a little bit different. I do want to take this chance to point out that I do have a tutorial for this all written out in the online textbook for my class here. So if you were to head into the lesson adding buttons and switches in the Arduino unit, you'll come up on this page. And then if we scroll through it, there's buttons and switches, and there's diagrams and all that kind of thing, and that should look kind of familiar. But we're going to be doing this, more or less. Actually, this is just a switch that interrupts the flow of electricity. It's not. It's another way to make a power switch, but we're going to be doing it slightly differently with, not that, this walkthrough. So this is a step-by-step walkthrough of what we're going to do. So you stick your button. We're going to connect all the power and ground. We've done a lot of this already, but this is where we're going to start doing new bits, and this will walk you through how you can wire up a button in order to work properly. I'm just going to leave this here for a moment while I get my wires ready to go. So we've got those, and I need my 10K ohm. So you'll notice that resistor in the diagram looks a little different than the one we've done before. I'm not going to go in and deep dive into all of the resistors, but just know that the different color bands on them tell you what the resistance is. I've just pulled out of the bag here the same one we have up there. That is a 10,000 ohm resistor. That's a fair bit more than the 220 ohms we see here with the LED. And I'll just hold them next to each other. And you can see that the bands are different colors in different orders. So that's how you can work that out. So in order to connect this up, what we're going to do is we're going to connect one side of the button to power, which I'm going to do just like this, to power, boom. And then on that same side, we're going to connect this 10,000 ohm resistor to ground. I'm just going to plug it in like that. And what this will do is, because there's a lot of resistance on there, whenever we press the button, the electricity is not going to flow to ground. It's going to flow through the basically we'll be able to tell that the sensor is happening whenever we press the button, because there's this big resistor on the grounding. So what we can do next is grab a longer wire. I'll make it I'll keep it a yellow one just because I have a lot of yellow ones. And looking at the button, we're going to go starting from that positive end. We're going to go diagonally through the button, and we're going to just plug this in on that same row as the little feet. And this is what we're going to plug into the Arduino. Again, if you kind of look here at the diagram, again, we're going from the positive end to the button, and then on the other leg on that same side, we're going through the resistor to ground, and then up here, we're going to go straight to whatever pin. If we look at the code, we're going to be connecting this to pin number 7. So I'm going to go find 7, and I'm going to be plugging this in right there, if I can get it in. The wire's a little bent. Get in there. There we go. Didn't think when I recorded this, the hardest part would be getting the little things in there. So again, just as a quick little refresher, because I've been recording this for a few minutes now, is basically we are going to set the LED pin to an output and the button pin to an input. It's going to be doing the same thing where it's going to turn on and off the LED. And to do that, we're just going to see whether or not the button is pressed. And then if it is, we're going to turn the LED on. If it's not, we're going to turn it off. My Arduino is still plugged into the same port and everything, so that's all good. So I'm just going to hit upload. We didn't get any errors. It's doing all of its thing. It actually stopped doing all of its thing before I could even get the camera down there to look at it. But if I click the button, we should see that turns on. So, yep. So again, I'll show you the circuit next. But as I click this, let me make it in focus. You see that turns on. This button is a little loose here, so there's a little bit of, I'll call it noise, but basically just errant electricity. So if I wiggle that button, you may see that it kind of comes on or not when we're not meaning to. That's just because it's not seated very well into the Arduino. When it's nice and in the hole properly, it's working just fine. So I'll kind of hold this in there with my middle finger, and as I press this, you can see that as long as the button isn't moving and making electricity move in weird places, that it is now functioning as a power switch. Again, there are other ways you can do this, but this is one where the Arduino is detecting whether or not electricity is flowing through the button, and then using that that bit of logic there in order to manually turn on and off this LED. So there's that. We can also see this in the code. Actually, not in this one. I got ahead of myself. I recorded a bunch of these codes the other day, and they're kind of all blending in my head. In the next bit of circuit building that we'll be doing, we'll see that when we start playing with the analog signals, because that's a little bit harder to work out the details. In this one, there either is electricity or there isn't, and that's pretty clear how to work with that. So that's pretty straightforward. Again, if your buttons are a bit wiggly, you may get electricity doing weird things. You may have different sized buttons. We can try this other button that I've never used before. I think that's actually the same size spacings, but it should ideally work the same. But this fits into the hole a little bit better. Yeah, it works the same. And this one, it sits in the holes a bit better, so it's not moving. And that's the basis of the digital inputs and outputs, having some kind of signal that is detecting is there electricity, and then your Arduino responding to that. The codes are very, very simple. The circuits, I wouldn't call them very, very simple, but they're not super complex. But by combining these, we can get very interesting results. So in terms of your components, most of them are actually analog components, what generally comes with your kit, but all of the LEDs we can work with. You'll have buttons of various kinds. You may also have some switches of various kinds that, again, you could utilize and just have something happen whenever you flip the switch. We'll see more of this stuff in the next video, so be prepared for that. But again, we'll be mainly focusing on LEDs as a kind of core piece to this this unit. So that's the end of this little video. Again, I'll go ahead and post this in its raw form up on YouTube, just so it's there, but then I'll be editing it together with the code video in order to set up, kind of a cohesive beginning, middle, and end that talks about the code that we did and the circuit that we built all in one spot. So that's going to be it for me, and I will see you all the next time I see you. Bye.